On the back side of 5.5. And if you recall, on the front side, in example A, we had just finished our first version of the side-side angle. Okay? And that was a situation where there was one triangle. It was straightforward. Okay? What we're getting ready to move into is the version where, if it's not obvious, there's two triangles drawn. Okay? So this is going to be the version where there's two triangles. Now, if you'll notice, they give us an angle, and the side opposite the angle is the shorter of the two given sides. So if I go back to where we were at yesterday, and I look here, the angle is acute, and the side opposite, so A is the smaller of the two sides, there are two triangles possible there. Okay? Now, I went to a couple of years ago because I cannot draw this picture to save my life. I have the pictures from the textbook here. The first triangle is this whole big triangle here. Okay, notice where angle A is 30, side A is 6, side B is 7. But then the second variation of this that we will look at is this little small one. So if you ignore the dotted lines, we have that little small triangle there, okay, which also has angle 30, opposite side 6, and the other side 7, okay? So those measurements could make either of these two triangles, okay? So let's start by going through the first triangle, okay? First triangle, you'll go through as normal. We'll have to tweak things a little bit to figure out our second triangle. So based on the fact that we have angle A, and side B. What do we have to find first? Think about it.
Angle B.
Yeah, we're going to have to find our missing B, aren't we? Okay. Now, I will tell you, you don't need as much room. Well, I don't know. I'm going to try and stay above kind of a midline here to work this one, because then I'll need room for my second one. So however you want to set yours up, but so I'm going to do sine A over A equaling to sine B over B. What do we know? Sine of 30 degrees over 6 is equal to sine of B that we don't know over 7. Okay? You do you when it comes to solving, right? I do cross products. You're going to see me do cross products every time. So I'm going to say 6 times the sine of B is equal to 7 times the sine of 30 degrees. And I'm going to bring mine up over here beside it so I could go a little bit lower, but what do we know then? If we solve for B, we're going to have sine of B is 7 sine 30 degrees divided by 6.
Divide by inverse.
Okay, take the inverse, yes. Yeah, it's not officially divide, but you got inverse. That's, I need you thinking inverse. That's what we need there. Okay, so it says sine of B. Remember, inverse is going to switch your B and that output. So B is going to be equal to the sine inverse of 7 sine 30 degrees divided by 6. And that's going to give me angle B. I just have one decimal place. What do we know?
Angle B is equal to 35.69 or 35.7 degrees.
Okay. So angle B, 35.7 degrees. Okay. We found B to be 35.7 degrees. What must we do next? No. We're not going to talk Pythagorean theorem at all.
Good.
But we're not going to. But we're not going to. Because your directions are to use law of sines. Now, in all honesty, I wouldn't say find the side next.
We do this.
How do we find it?
35.7, 30, 180.
Okay. Find the missing angle first. And if we find the missing angle,
I'm confused on the way that the two triangles apply to this.
hold your thoughts. We'll get there. I'm going to put this up above just so I have more room for my other part. So you guys remember, angle A plus angle B plus angle C equals 180 degrees, right? So with that in mind, what did we have? 30 degrees plus 35.7 degrees plus whatever angle C is 180 degrees. What did you guys find angle C to be?
114.3 degrees.
Okay. 114.3 degrees. And what should be your last step since I'm vetoing Pythagorean theorem?
Use this sign.
Okay. Using law of sines. And so I'm going to personally go back and use A's because A's were given and they're not rounded values. Okay. So it makes it a better answer.
Wait, are we not supposed to go to the bottom part of this right?
Well, you need room to do the second one. So, I mean, you could a little bit off to the side. And here's what I will say. If you're running out of room and you need to adjust things, we're not going to need very much room for C. Okay? We're not going to need a ton of workspace for C. So you can run off to the, into C a little bit. But so sine of A over A equaling sine of C over C. Do the math here, right? Sine of 30 degrees over 6 equals sine of, what is my C? 114.3 degrees over C that I'm trying to find. Okay? If I multiply my cross products and then divide, I'm going to have 6 times the sine of 114.3 degrees, and then divided by the sine of 30 degrees for my other diagonal. I have one decimal place again, which is 10.9. Okay, so that is the first triangle. That is the triangle that, if you ask, that's a natural triangle, right? That's a triangle that just goes with all the other ones we know how to do. It flows. Now, the option, if you go back and look at the front page, it says there's one where, and it would be angle C in this case. Angle C is obtuse, which is what we just did. There's also one where that side 6 can slide underneath, and angle C is going to be acute. Okay, because mathematically, this side of 6, while it could be out here like we just did, it could also slide underneath here. Okay. Now, the key is, if we start the second part of this problem just like the first part, aren't we going to be redoing the same steps, getting all the same answers? We are. So we have to start a little bit differently. And we're going to find angle B a little bit differently. Notice, in dotted lines, the original angle is here, yes? So what did we just find angle B to be? The original angle B was over here. And so we found that angle up above to be 35.7 degrees, yes? Before we moved that piece. This side also had a length of 6, yes? Okay. Look at what's happening here. If you ignore the purple piece of the triangle there, okay, and you look at this dotted triangle piece, including that piece right there. There's something special going on with that triangle, which helps me. This right side is side 6. And what about this left side? It's side 6. If those angles are, those sides are the same, the angles opposite them are going to be the same. So what I know here is that if this is 35.7 degrees, this piece right here is 35.7 degrees. And what that allows me to do in my new little skinny purple triangle is to find a different version of angle B. How can I find a different angle B here? How is my previous angle B going to be related to my new angle B?
It's going to be 180 minus 35.7.
What you're going to say, Eli?
Sorry.
Okay. So the idea, do you guys see the straight line? The straight angle, yes? So in order to find your new angle B, you're going to be subtracting from 180. So we're going to be doing 180 minus our previous angle B. And what is 180 minus 35.7? Bless you.
Thank you. For argument's sake.
My notes say 144.3 degrees. Okay. So that's the new part you have to do. Now, it gives you a new angle B. It gives you a much bigger angle B, right? So angle B is obtuse now. Finish the problem up. There's angle B. What else do we know? What else can we find?
Well, so we know we can find angle C.
Because all three angles in a triangle still add up to be
And then we can find,
180.
we just have to find the sides.
Yeah. So angle A all along has been 30. My new angle B is 144.3 plus what angle C is equals 180. So my new angle C this time is going to be
5.7.
5.7 degrees, very small. And you can find your new side C, yes?
Yeah.
Still using law of sines. So we're still doing the same piece we just did up above, where it's sine of A over A and sine of C over C. So sine of 30 over 6, which I think I seriously have memorized now, over sine of C. So my new C is sine of 5.7 degrees divided by side C. I like to do cross products. So C times sine of 30 equals 6 times sine of 5.7. So if I go ahead and do this in one step, 6 times sine of 5.7. And then since it was C times sine of 30, we're going to be dividing by sine of 30. And C is
1.9. I know.
I have 1.2 written in my notes.
Oh, sorry, 1.19.
Ah,
And then the
that makes a difference. Okay, guys. That's the two triangles. Okay?
So how are we going to draw this on their own? Yeah.
Go back and trace the triangles in your notes. I don't know. You don't necessarily have to draw the
I'm
triangles.
not going to be able to see it.
Yeah. I would go back and use draw a triangle similar to this.
I think
Okay. Okay, and as I said, I struggle with drawing these triangles on my own. And that's just my lack of artistic.
They don't
But
look pretty. I just need to know.
draw a big triangle that's slightly not, equilateral or isosceles. And then basically what you're doing is you're just, taking this line of 6 and you're drawing it over here also is what you're doing there. So, I know, it's going to have to be a practice thing. Okay, now, we do need to talk about C. I said you didn't have to leave a ton of room for it, right? So let's go look at C. I have mine on the next screen, yeah. Solve triangle ABC, given that A is 8, B is 15, and angle A is 100 degrees. I'm going to draw a picture.
Oh, yeah.
It does say that angle A is 100 degrees. So I'm drawing mine with an obtuse angle of 100 degrees. Tells me that side A is 8 and side B is 15. And it doesn't really matter which side you make the 15.
No triangles.
Why?
Because A is obtuse and then A is less than or equal to B.
Okay. In basic words,
Largest angle.
you have an obtuse angle. There's only going to be one obtuse angle in a triangle. Think logically here, right? There can only be one angle more than 90. So we have an obtuse angle. 100 will be the largest angle. The largest angle must be across from the largest side. There's a side larger than 8, and it's not across from the 100. So obtuse angles must be opposite the longest side. So no triangles possible. Okay, so I kind of gave myself away earlier when I said you didn't need that much room for this one. That was your hint that there was going to be no triangles possible. But, so, I'm writing down obtuse angle must be opposite the longest side. That's my reminder to you. Obtuse angle must be opposite the longest side. No triangles possible.
Okay, I just kind of wrote no triangles possible.
And that's fine. But if you're looking at this while you're doing homework and trying to figure out why was this no triangles possible, there's your note to yourself. You guys know, I'm going to write lots of stuff here. Doesn't mean you have to write it all. You write every little bit of it. You can write every little bit of it more, or you can write less than me. Your notes. Okay, we have 2 word problems. Ready to talk? Now, word problems. We're talking law of signs. So obviously the key is going to be we're going to use law of signs to solve them, right? It's trig. We're going to need a picture. Okay? So, Forest Ranger Chris Johnson at Ranger Station A sights a fire in the direction 32 degrees east of north. Ranger Rick Thorpe at Ranger Station B, 10 miles due east of A, sights the same fire on a line 48 degrees west of north. Find the distance from each ranger station to the fire. Okay? Now, one piece of information you should probably walk into this problem with. Do you know your directions? Or are you directionally challenged? On paper, do you know your directions? That's all that matters here.
If I ask for directions and somebody goes, oh, just go west. I'm like, what?
Okay. I'm old school. I say never eat shredded wheats. Or you guys never eat soggy waffles, or are you something else? As I said, I'm older than you guys.
Yeah,
I just kind of know.
You just know it. That's fine. Okay. Whatever it is, know your directions, because that's going to, we have to have everything relationally placed, right?
I think they told us to never eat soggy waffles. So.
Yeah.
Yeah, that's what I. I don't know. Do they even sell shredded wheats anymore?
Is it like a cereal or something?
It was a cereal, yeah. I have no idea. Okay. So, we have a ranger station A, and we have a ranger station B. Now, notice, ranger station A and ranger station B. Ranger station B is 10 miles due east of A. Ranger station B is 10 miles due east of A. East is a
Is due
horizontal thing, right?
Is due just like straight east?
Like, yeah, directly east, yes. Okay, so with that in mind, I'm going to put A and B on the same horizontal. Now, which one's which? B is east of A.
So B's the right one.
So B is east of A. And what do we know about these two? They are 10 miles apart. Yes? Now, and I kind of skipped that because I knew it would be helpful if we got that set up first. Forest Ranger Chris Johnson at Ranger Station A sights a fire in the direction 32 degrees east of north. So 32 degrees east of north is if you're looking north to the east, which is going to be on paper to the right. So the idea here, I'm going to put my fire up here. Or if we have A and B, what could I call the fire? I could call it C if you want. You draw a fire. I'm going to call it C or fire. Now, the idea, 32 degrees east of north. Okay, north is on paper directly up, yes? So 32 degrees east of north, beware, 32 degrees is that angle right in there. It's not inside the triangle. Do you see that? Because you have north here. East of north is saying, okay, that line of sight to the fire is 32 degrees over from the north.
So if it was north and east, then it would be on the inside of the triangle?
Then we'd be going to the, I guess.
It would be that angle
Because-
right there.
Yeah, it would be. Okay, now, focus. From fire station B, the same fire, 48 degrees west of north. So from here, he sights the same fire, so there's his line of sight, west of north. So north is looking directly up on the paper. To the west is to the left of it, and so that 48 degrees is that right there. Okay. That's your given. Find the distance from each ranger station to the fire. So I want to know this distance from station A to the fire, and I want to know that distance from station B to the fire. Which means really, if you're thinking in terms of ABC, I need to know side A and I need to know side B, right?
Yep.
Now, what do we know about angles?
So first, we can find the angles of A and B by subtracting both those numbers from 90.
Subtracting from 90 makes sense because an east-west and a north is going to create a 90-degree angle, yes? So the idea that if this guy is 32 degrees, inside here is going to be 90 minus 32. And what's 90 minus 32? 58. Over here, same thing. We've got a right angle happening. So 90 minus 48 is going to put us at 42. What about angle C?
Let's use something sort of. Well, we should.
What about angle C?
Angle C would be 70 degrees because 180 minus 58 minus 52.
Is what?
You said angle C?
Yeah. What do you say it is?
70.
Not what I've written
I
down my
had-
notes.
Sorry, I had 52 written. No, so it would be
Okay.
or 52.
And that's just all three angles and triangle equal 180, yes?
Yes.
It's like, okay, did I write something wrong or where are we at here? Okay, guys,
No, just
we're ready to do the problem,
90 minus 48 is 52.
okay? And the hardest part on this was setting up the picture. This is no different than any of the other problems we've done. Our job is to find side A and side B. How can we do that?
So we can set up sine of 80 over 10 and then set of equal to over 2.
Does that make sense? Because basically 80 is angle C and side C is 10 long, isn't it? Okay, so with that in mind, set it up. Okay, so if we use sine C, because that's the given, right? And then if you do sine A over A, so then I'm using sine of 80 degrees over 10. Those are my matching C's. If we start with sine A, that's sine of 58 degrees over side A. So what I put into my calc there is going to be 10 times sine of 58 degrees divided by sine of 80 degrees. What are you finding side A to be?
8.6 miles would be the distance from station A to fire.
Check that though. Side A is 8.6 miles, but what distance is that?
Station B.
Side A is over here. It goes from station B to the fire, yes? So this is station B to the fire. Okay? And then you have your one other to find, don't you? I again would go back and use my C's. And just this time I'm going to use them with my B. So still using sine of 80 degrees divided by 10. Sine of angle B is 42 degrees divided by side B. So in order to find side B, I'm going to do the cross product 10 times sine of 42 degrees, and I'm going to divide it by sine of 80 degrees. Works out to be 6.8 miles. And that is, it's side B, but it's a distance from station A to the fire. Okay? Get the picture drawn, it's a piece of cake, right? I don't remember if they give you a picture. I feel like there's one like this in homework. I don't remember if they give you the picture if you have to draw the picture. So do check. Sometimes they give you the pictures in the book. It's nice when they do. So, okay. Well, I was nice in the next example. I gave you a picture because the next one is a really hard picture to draw, if I recall. Okay. A road slopes, and this is the hard part of this one, 10 degrees above the horizontal, and a vertical telephone pole stands beside the road. The angle of elevation of the sun is 62 degrees, and the pole casts a 14.5-foot shadow downhill along the road. Find the height of the telephone pole.
What?
Now, there's a reason there's a picture provided, yes? Because this one is a challenge without the picture. Okay, so road slopes 10 degrees above the horizontal. So you see the 10 degrees here, right? So the road being that solid black line. You got the vertical telephone pole. The angle of elevation of the sun is 62 degrees, so that's the sun shining down. They have the angle marked there, 62 degrees. Now, where is this? The pole cast a 14.5-foot shadow downhill.
That dark black line. Oh. The other side. Oh,
The shadow of the phone pole is right there between A and B, because notice it has the little cross sections of the phone pole. I don't even have that labeled in my picture, but I'm going to try and, I don't know if you can squeeze that in there or not, but
Oh, we can get this trust. Yeah.
so that side is 14.5 from A to B, or we could even just say C is 14.5 because they do have it labeled as side C. Okay.
Yeah.
Now, find the height of the telephone pole. What are we being asked to find?
Hey.
A. Now, what?
Angle A equals 62.
Is angle A equals 62?
I agree. No.
Not quite.
No, I believe angle A.
I don't.
No, angle A does equal 62 if you do math.
Oh, yeah. It's like 92.
No,
Math.
because so that angle, what we would call like probably angle C, would be equal to 28, and then you got 90 with angle B, and so angle A would equal 62.
Angle B is not 90.
Ow! It's a telephone pole into the ground.
But there was this thing about the road slopes 10 degrees above the horizontal.
Your point?
And go for, and this is why the picture's drawn here. It has, it's that funky 10 degree slope.
Now you can tell me B's not
Now,
correct.
guys, the telephone pole makes a right angle with what line looking at the picture?
The ground.
It makes a right angle right there. That's not a right angle. Now, we're talking about this dark black line is the road, okay? Here's the deal. Here, this is 10. This telephone pole makes a right angle with this dotted line. If this is 10, what's this right here? 80. Now, we have a straight line with the dark black and the shadow of the phone pole. So what's going to be on the other side of 80 here? Angle B is going to be what? Did I hear it? 100? There's a straight line there. There's a straight line. So if you know 80, the other piece of that is 100. Now, we have 100 here. What'd you guys say the angle at the top was? And why did you say 28?
Because the the vertex angles or whatnot, they're like back to back, you got 62, and then you know those two hopefully make a right angle.
Okay. Yeah.
I'm unsure what a right angle looks like now because
That's the. Okay. Okay, so I do agree with the 28. The fact that you've got the 62 up here, you do have what forms a right angle of 90. Okay, and so that does leave that piece to be 28. Okay. And then, do we need, yeah, we probably should find angle A. We do need angle A. What's angle A?
52.
Because all three angles in a triangle add up to be 180. Now, side C, we already decided was 14.5. We're finding side A. Well, if we know we're talking about sides A and C, we should also probably talk about angle C and angle A for our setup. What is angle C?
28,
That's the 28. What's angle A?
52.
52. Can we use that information right there to find our answer? It's law of sines, right? So, did we even need any of the B information?
Yeah.
Not,
Well, kinda.
not in our solving. We needed it along the way to find stuff, right? And so, sine of A over A equals sine of C over C. So sine of 52 degrees over A equals sine of 28 degrees over 14.5. Cross products. A times sine of 28 degrees equals 14.5 times sine of 52 degrees. So I personally would be plugging in 14.5 times sine of 52 degrees divided by sine of 28 degrees. What's the calc there giving you?
24.3, 33, something, 8, 9,
24.3 what?
feet.
Feet. Okay, guys. You have 2 through 12 evens, 20, 22, 38, and 39. Due tomorrow. We'll start with homework questions. And then we will, after we get homework checked and homework questions, then we will move on to law of cosines.